Now we have a question on the board, and the question says we should find the reactions at point A and point C, and also do the shear force and bending moment analysis. Alright, so the first thing we do is to obtain the reactions at point A and point C before carrying out the analysis. So as always, the free body diagram. So we break down the beam. On the beam we have a 10 kilonewtons force at the middle of the beam. So we have 10 kilonewtons force. Alright. At point A, we recognize that this is a pin. And for a pin support, we always have a vertical and horizontal reaction. Alright, so in place of A, we'll now use this RAY, vertical reaction, and then horizontal reaction with this RAX, all at point A. At point C, we have just a ruler. And for a ruler, we have only one reaction, normal to the surface. Alright, so it's synonymous to saying RCY at point C. This point B. Their distance apart are equal 2 meters and 2 meters. 2 meters, 2 meters. So the first thing to do is to obtain the reactions at point A and point C before we can carry out the shear force analysis and as well the bending moment analysis. Alright, to do this, in the first series of applied techniques, where I talked about two-dimensional force, I talked about what is called static equilibrium equation. So please do well to go through the first video on 2 dimensions so you can be able to understand it. So I talked about static equilibrium equation, and I said the static equilibrium equation is simply the summation of force in the horizontal axis, summation f of x is equal to 0. Also, summation of force in the vertical axis is also 0. Summation f of y is also 0. And then in the straight dimension, that means summation of force in the z direction is also 0. That is if it is straight dimension. So we are going to apply this law to solving this problem. So from static equilibrium law, we have that summation f of x is equal to 0. So that simply means that sum of all the forces in the x direction, that's horizontal forces, sum of all the horizontal forces is what? 0 for static equilibrium to take place. Alright, for that law to be obeyed. And when we check on this beam, RAY here is vertical, RCY here is vertical. So we do not have any other horizontal force apart from RAS. So it means now that this simply implies that the reaction at AX is simply what? 0. That's what it implies. So RAS is equal to 0. That's the first law obeyed. Summation f of x is equal to 0. The sum of all horizontal forces is equal to 0. The next is summation f of y is equal to 0. So we sum all the vertical forces, considering upward force as positive and then downward force as negative. If we know this, we have RAY as an upward force, and it's positive because it's pointing upwards. So we have RAY positive. The next force we have on the beam is 10 kilonewtons acting downward, so it's negative. So we have minus 10 kilonewtons. Okay, the next force we have is RCY upward, so it's positive. So plus RCY, and that's equal to 0. Okay, so let's do a little equation. This is a linear equation with 2 unknowns, which is very impossible to solve. Alright, because if I try to send minus 10 over to this side of the equation, you have RAY plus RC y to now be equal to negative sign plus an equal sign becomes positive. So we have 10. So let's call this equation 1. Equation 1 happens to be a linear equation with 2 unknowns, which is highly impossible to solve. The only way we can make a break for this is by applying another static equilibrium law. And that static equilibrium law also states that summation of moments of a force about a point is 0. Okay? So the moment of any force about any point is 0 from also static equilibrium law. So we take moment at point A or point C, take moment at any of the points, you obtain the same answer. But let's take moment at point A, since we have two forces at point A, knowing that moment of those two forces at that point is 0. Alright, so take moment at point A. Alright, so we'll take summation of moment from the law at any point, in this case point A, is equal to 0. So let's consider forces acting clockwise to be positive. That means anti-clockwise moment should be what? Negative. So clockwise moment is positive, anti-clockwise moment is negative. So you check our direction of force. We said if the force takes moment about this point in the clockwise direction is positive. If it's anti-clockwise, it's negative. So we've already established that moment at point A is 0. So it means that the moment of this force ROAY and ROS at point A is what? 0. Simply because moment is force times distance. And if we are taking moment at point A, the force at point A remains ROAY and ROS. But there is no distance between those forces and that point. So that means the distance between them is 0. Since there is no distance, it means 0 times the force. And 0 times force is simply what? 0. That is why we have this law. Summation of moment at a point is always 0. So if that's the case, it means therefore that we have to take the moment of this other force, the 10 kilometers force, and the moment of RCY about point A. And if I take moment of 10 kilometers force about point A, notice the direction of the moment. This force is acting downwards. So therefore, if we turn it to this point A, it goes like this. So it is a clockwise moment. If we turn the force to point A, it goes clockwise, so it's positive. Alright, so we have 10. Distance it takes the 10 kilometers force to meet point A is simply what? 2 meters. So this is 10 times 2. Similarly, we have RCY pointing upwards. The moment of this force will go in this direction. This is the force pointing upwards. So we have the moment about this direction to get to point A. And this is what? Our anti-clockwise direction, which is negative. Anti-clockwise direction is negative. And the distance RCY takes to get to point A is simply 2 plus 2, which is what? 4 meters. That's the length of the beam. So this force will take this total distance to get to point A, 2 plus 2, which is 4 meters. So it becomes 4, the force times the distance 4. And the force is simply, remember it's negative because it's anti-clockwise. So minus RCY times 4. And we already established that summation of moment about point A is 0. So it means the whole of the moment is equal to 0. Okay, so we open our brackets. 10 times 2 gives us 20 minus 4 times RCY will give us 4RCY, and that's equal to 0. So let's transfer this term, the negative term, to this side of the equation. Of course, negative plus an equal sign becomes positive. So we'll have that 20 is equal to 4RCY. And in order to obtain 4, we divide both, in order to obtain RCY, we divide both sides by the coefficient of RCY, which is 4. Alright, so it means now that RCY is simply 20 divided by 4. And therefore RCY is simply 20 divided by 4 is 5. So 5 kilonewtons. So it means the reaction at point CY is simply 5 kilonewtons. Now, knowing RCY, and we have equation 1, we can substitute the value of RCY into equation 1 as 5. Then we can find the value of RAY. Alright, so from equation 1, from equation 1, we have that RAY plus RCY is equal to 10. Already we know what RCY is. RCY is 5. So in place of RCY, we have RAY plus 5 equals 10. Okay, so RAY now, let's send plus 5 over to this side of the equation. Plus and equal this time becomes negative. So we have RAY is now equal to, bring down 10, this comes here becomes minus 5. So that simply implies now that RAY is simply 10 minus 5 is also 5 kilonewtons. So we've now been able to obtain the reactions at the beam. We'll find the reactions. First of all, RAX is 0 established, and then we have RAY and we have RBY. So the beam becomes this. We have a 10 kilonewtons force, and then we have 5 kilonewtons force here. We also have 5 kilonewtons force here. This point C, point B, and this point A. The distance apart 2 meters. 2 meters. Alright, so let's start our shear force analysis. Now, shear force simply means summation of all the forces acting on a beam from one point, from the beginning of the beam to the end of the beam, considering upward forces as positive and downward forces as what? Negative. That's what shear force is. So you sum each of the force from the beginning of the beam at each point to the end of the beam. Now, this is what I mean. We have the force at point A to be what? 5 kilonewtons, and it's an upward force, so it's positive. Alright, so it means that shear force at point A, so we use S dot F to represent shear force. Then A represents at point A. Shear force at point A is simply 5 kilonewtons. So the force at point A is 5 kilonewtons. The next move to point B, so we have shear force at point B, S dot FB. Alright, so the last shear force we had was 5 kilonewtons. So this same force moved till point B. So we still have that same 5 kilonewtons force till we get to point B. At point B, we experience that there's a downward force of 10 kilonewtons. And that force is what? Downward, so it's negative. So we have minus 10. Okay, so of course, 5 minus 10 will give us minus 5 kilonewtons. Now, please take note. At the end of every shear force and bending moment analysis, we must always obtain 0. If you don't have 0, it means you're wrong. So at the end of every shear force analysis, at the end of every bending moment analysis, you must always have 0. Alright? So we have shear force at B is now minus 5 kilonewtons. So this same minus 5 is what moves from point B down to point C. So we have shear force at point C. So we have minus 5 kilonewtons moving from point B down to point C. At point C, it encounters an upward force, and that force is 5 kilonewtons going upward, so it's positive. So we have, since it's positive, we have plus 5. So this is minus 5 plus 5, and the answer is simply 0. At the end of every shear force analysis, you must always have 0. At the end of every bending moment analysis, you must always have 0. Okay, so that's that for shear force analysis. So let's go with the bending moment analysis. Bending moment analysis. Alright, just like the shear force, bending moment is simply the moment of the force from the beginning of the beam to the end of the beam. The moment of the force, moment is usually force times distance, as I always said. So from the beginning of the beam, gradually to the end of the beam. And in this case now, we will consider upward forces to have positive moment and downward forces to have negative moment. Please take note of that, because we are moving from the beginning to the end of the beam. So there's no point in doing clockwise or anti-clockwise. Just know that upward force will have a positive moment and downward force will have a negative moment. Alright. At point A, we have a 5 kilonewtons force. The moment of this force about point A is 0, because moment of the force about a point is 0. So the moment of 5 kilonewtons force about point A is also 0, because there is no distance between the 5 kilonewtons force and point A. So the distance between them is 0. So 5 times 0 gives us 0. So moment at A and at point A is equal to 0. Take note. Alright? At point B, the same thing happens. At point B, the moment of 10 kilonewtons force at point B is 0, because 10 is just at point B and there is no distance between 10 and point B. So moment is 10 times 0, which is still 0. But before we get to point B, we move from point A to point B. At point A, we already have a 5 kilonewtons force and it's upward, so it's going to have a positive moment about point B. So the distance it takes point A to get to point B is simply what? 2 meters. And since this force is upward, is positive, it's going to have a positive moment about point B. But the moment of 10 kN force about point B is 0. So the only force that has moment now is 5 kN force about point B. Remember, from the beginning of the beam till the end. Alright, so moment at point B is now equal to, we have 5 times distance 2. This is 5 times 2, and that's equal to 10 kilonewtons meter. That's now the moment of this force about point B. But the moment of 10 kilonewtons force about point B remains 0. We now move down to point C, moment at point C. Similarly, the moment of this 5 kilonewtons force about point C is also 0, because there is no distance between this 5 kilonewtons force and point C. So it becomes 5 times 0, which is 0. But before we get to point C, we have to pass through A, pass through B to get to point C. And between these intervals, we have two forces existing to get to point C. The first force is the moment of force, the 5 kilonewtons force about point C. Since it's upward, take it as positive. So the moment of this force about point C is simply 5 times the distance it takes to get to point C. And that distance is what? 2 plus 2, which is 4. Alright, so we have 5 times 4. Positive because this force is upwards. Alright, now another force that has moment about point C is 10 kilonewtons force. And this 10 kilonewtons force acts downwards, so it will have a negative moment about point C. And the distance it takes the 10 kilonewtons force to get to point C is simply what? 2 meters. That's from point B to point C. It's simply 2 meters. Alright, so we have minus because this force is acting downwards. Then 10 times distance it takes, which is 2. You have 10 times 2. Okay, so this is equal to 5 times 4 is 20 minus 10 times 2 is also 20. So the moment at point C is equal to 0. Again, take note. The bending moment analysis is always 0 at the end. The shear force analysis is always 0 at the end. Take note of that. Now, when we're able to do the analysis, we now have to plot the shear force diagram and the bending moment diagram. The shear force diagram and the bending moment diagram. So I'll take you through a very beautiful shortcut through which we do this. So the first thing you do is to bring the beam. So we have the beam. We have a 10 kilonewtons force here. We have a 5 kilonewtons force here. And then we'll have another 5 kilonewtons force as well. Okay, so what you're supposed to do is on a graph, but then you can as well use the freehand. It's allowed. So all you do is trace down all the force. Trace down all the points of the force. Trace down all the points of the force. Okay, now we'll now check the analysis for shear force. The highest value for shear force is plus 5, and the lowest value for shear force is minus 5. Minus 5 is the lowest value. Alright, so let's keep this as our origin. So this is the 0 point for the shear force analysis. So let's call here plus 5 kilonewtons. So we are starting with the shear force first. So this is the origin O on the 0 axis. That's the origin. Then we have the lowest force, which is minus 5. So from the origin, upwards is positive, downwards is negative. And we'll have minus 5 downwards. Minus 5 kilonewtons. So what you do is this: you trace out all the points. Trace out all the points. So let's take the shear force individually. Shear force at point A is 5, positive 5. Okay, so this is point A, and this is positive 5. So it means this is where the shear force is. Well, shear force at point B is negative 5. This is point B. This is negative 5. You pick out the point. You asterisk. And then shear force at C is 0. And of course, this is 0 line. This is point C. So you asterisk 0 line. Now, the shear force diagram for a force, for a point load, take note, we are going to talk about different loads. We'll talk about the point loads, we'll talk about uniformly distributed loads and uniformly varying load and lots more. I will give a brief introduction to that on its own. But the shear force diagram for a point load is simply a very straight line, is simply a straight line. The shear force diagram for the point load is simply a straight line. Alright, so 5 kilonewton force moved from point A to point B, and then at point B, we now have the next shear force to be -5. So it came down from point B down to -5. So you have this down to -5. This -5 from when you move to point C, and at point C, it moves up towards 0. So you have this. So from the origin, the 5 kilonewton force, and it can be depicted here. From here, this 5 kilonewton force is an upward force. So from the origin, we have an upward force. So this force moves, this 5 kilonewton force moves till point B. At point B, there is a downward force of 10 kilonewtons. So we have, of course, if here is 5, here is 5, it gives us 10. So there is a downward force down toward 10 of 10 kilonewtons. We experience the downward force here. This 10 kilonewtons force moves till point C. At point C, we experience an upward force to the beam of 5 kilonewtons, which is what we have here. Upward. This is 5 kilonewtons upward and it's positive. Alright? So this is our shear force diagram. So you can just see. So you use S, F, D, shear force diagram. Okay, so the next diagram we'll talk about is the bending moment diagram. The highest value for the bending moment is 10 kilonewtons. The lowest value is 0. So like always, you bring out your origin, O. So this is our origin, O. That's 0 mark. And the highest value for bending moment is 10 kilonewton meter. So this is 10 kilonewtons meter for the bending moment. So the moment at point A is 0. Okay, so do well to trace this out. Moment at point A is 0. This is point A. Moment at point A is 0, and this is 0 line. So you are steady. Moment at point B is 10 kilonewtons. 10 kilonewton meter. And this is point B. This is 10 kilonewton meter. So you are steady. The moment at point C is 0. This is point C. This is 0 line. You are steady. Alright, so take note, the bending moment diagram for a point load is simply a slant line. Now, this is what we call a point load. In a load that is acting either downwards or upwards, they are called point load. Take note of that. So the bending moment diagram for a point load is simply a slant line. So from origin we have a slant line to point B, then from point B down to point A. So these are the bending moment diagram. So you connect all the points from point origin, point A to point B, from point B down with a slant line. So this is the bending moment diagram. So this is bending moment diagram. Alright guys, that's it. That's the shear force and bending moment analysis with their diagrams displayed already. Alright, so I will see you in the next video with more questions on shear force and bending moment analysis. Please, I know you like the video, of course. Don't forget to like and of course subscribe, and of course invite your friends for more subscribers. Thank you very much. I will see you in the next video.